In this video we'll be looking at section 10.3, segments and their measures. Oh, scratch that. That is not what this is about. This is about distance and midpoints. So we're going to be looking at 10.3, distance and midpoints. So our essential question today will be how do I find the distance and midpoint between 2 points? How do I find the distance and midpoint between 2 points? Now for the distance, we'll use what is known as the distance formula. So say we're trying to find this distance right here, distance d. The distance formula is d, that's this segment right here, is equal to the square root. And we'll need a big square root because we're going to do a lot of math underneath it. We'll take the x2 and subtract the x1 in parentheses. Then after we subtract, we'll square that value. Plus, and then we'll do y2 minus y1. And we'll square that value. So we'll have to use our order of operations. So we'll do both subtractions first. Then we'll square both numbers. Then we'll add the two together, and then we take the square root. So order of operations, parentheses, subtract in parentheses, square both numbers, add results for find the square root. Okay, so if we use a labeling system and then we plug in, then we follow our order of operations, we should be okay. So let's see if we can do this. So let's label this. This is my first point, so I'll use x1, y1. So this will be x1, y1, and this will be my x2, y2. So I'm going to plug into my distance formula right there. Distance equals, we're going to use this formula. So I'll say that the distance is equal to the square root x2 minus x1, 2 minus 3. Then we'll square that, plus y2 minus y1, 0 minus 2. Then we'll square that. Now let's simplify. So first we subtract in our parentheses. 2 minus 3 is 1. Negative 1, I should say. Plus 0 minus 2 is negative 2, and we'll square that. Now we'll square both numbers. Distance is equal to negative 1 squared would be 1, plus negative 2 squared would be 4. Now we'll add those two numbers together. We're adding the results of squaring. So distance is equal to the square root of 1 plus 4 is 5. Now this is not a perfect square root, so we'll have to do an approximation, and this is approximately equal to 2.2. And that's how we do it. Plug in to our distance formula. Then we subtract in parentheses first, exponent second, so then we'll use the square, squaring both numbers. And then we'll use our addition on the inside of our radical of our square root symbol. And then using a calculator, we can find that the square root of 5 is approximately equal to 2.2. Okay, so what I'd like you to do is pause right here. See if you can try b on your own. Plugging into our equation and then simplifying following the steps. So pause right here. See if you can find b on your own. So if you tried letter b on your own, let's look at it together. So we'll have d is equal to the square root. I'm going to use my labeling system. x1, y1, x2, y2. Let's plug in. So I have x2 minus x1, so 0 minus 0. Then I'll square that, plus y2 minus y1, so that's negative 3 minus 4, and then I'll square that. So distance is equal to, simplifying my parentheses, I have 0 squared plus negative 7 squared. So I have distance is equal to 0 plus 49. 0 squared is 0, negative 7 squared is positive 49. Distance is equal to the square root of 49, which is equal to 7. So let us now try letter C. Okay, letter C is interesting because remember we're going to end up with a negative minus a negative. So be careful with that minus and negative. So I have distance is equal to the square root of, so here's my x1, y1, x2, y2. x2 minus x1. So negative 3 minus a negative 4 plus 4 minus 11. And then we'll square that. So minus and minus becomes plus. So we have distance is equal to the square root of negative 3 plus 4. So that'd be 1 squared. Negative 3 plus 4 plus 4 minus 11 would be negative 7 squared. So the distance would be equal to 1 squared is 1 plus negative squared is 49. So we get the distance is equal to the square root of 50, which is approximately equal to 7.1. Rounding my answer. So I rounded my answer to get 7.1. Okay, so let's look at bisecting a segment. So first we'll want to talk about a midpoint. Well, a midpoint is the point halfway between two endpoints. Midpoint is a point that is halfway between two endpoints. So in our picture right here, B is the midpoint between between A and C. So we can say that AB is equal to AC because AB is cutting this AC in half. A segment bisector is a segment, ray, or line, or plane is a segment, ray, line, or plane that intersects a segment at its midpoint. So in essence, what that means is it's cutting the segment in half. It's any one of these things, segment, ray, line, or plane, and it's cutting that given segment in half. A perpendicular bisector is a segment bisector. So it's any one of these things that's cutting a segment in half, but is also, perpendicular to the segment. So say we had lined segment that looked like this. We'll say that this is about the half, so we'll call that our midpoint. It would be perpendicular, meaning creates right angles like that. And we would say that these two are congruent. So if we have A, B, and C, AB is equal to AC, just like above, but now our DE is perpendicular to AC, so it creates right angles at all four of these angles. All four of these angles will be right angles. So our midpoint formula would be something like, looks something like this. XM is equal to X1 plus X2 divided by 2, and YM is equal to Y1 plus Y2 divided by 2. So it's essentially the average of the two endpoints. And so that would look like, so we'd have a point XM comma YM. Okay, so let's look at this first example. Find the coordinate of the midpoint given the endpoints. So I'm looking at, so we're finding, so we are find the midpoint. We're going to use our formulas. I'm going to write these over here in our margin as a reference. XM is equal to the average, x1 plus x2 divided by 2. And ym is equal to y2 plus y1 plus y2 divided by 2. So we'll be using those. Remember that we're finding a point, so we always want to label it as a point once we find the values. So let's find our xm first. Xm will be equal to x1 plus x2, so x1 plus x2. 3 plus negative 4, and we divide that by 2. So we get our midpoint is equal to negative 1 over 2. Now our y midpoint will be equal to y1 plus y2, 5 plus 0 divided by 2. So that would be equal to 5 over 2. So our midpoint would be negative 1/2, comma, 5/2. And that's all we do. We add the x's together and divide by 2, add the y's together, divide by 2. If it's a fraction, we leave it as a fraction. And if it can simplify, we would simplify. So let's try b together. Xm would be equal to x1 plus x2, 0 plus 4, divided by 2. xm would be equal to 4 over 2, so xm equals 2. Y, the midpoint for the y's would be 0 plus 6 over 2. That's 6 over 2, so ym would equal 3. So we'd have the point 2, comma 3. So at this point, what I'd like you to do is try number C. Try letter C on your own. So pause right here. Try this on your own and see if you can do that yourself. Okay, so hopefully you try and letter C on your own. So let's try this together. xm is equal to 2 plus 0 over 2. So that would be 2 over 2. So xm is 1. And then our y coordinate would be 4 plus negative 8 divided by 2. So that's negative 4 divided by 2. So that would be negative 2. And so we get the point 1 comma negative 2. So that's our midpoint, 1 comma negative 2. Okay, so we have one more piece to do, and then we'll be done with this section. And for that, what I'm going to do is, what if we're given a midpoint, and then we want to kind of go in reverse to find the other coordinate? So let's look at 3. Find the coordinates of the other endpoint of the segment given an endpoint and the midpoint m. So m is our midpoint, and this is one of the endpoints. This is, say, our x1, x2, and this is going to be our xm, ym, x1, y1, xm, ym, and what we're trying to do is find x2, y2. So let me show you how that works. So let's label everything, x1, y1, because this is the point given, one of the endpoints. This is our midpoint. So this is our xm, ym, like so. But we're going to use the same formulas from right here. But now I'm just going to plug in where I need to plug in and then solve for the x2 and y2. I'm going to be solving for x2, I'm going to be solving for y2. So let's plug in and see what happens. So I have xm2 is equal to x1, which is 6, plus my x2. I'm just going to label it x because it's the only variable I have, and I'll divide that by 2. Now here's the process. First, I want to get rid of this division by 2 first. So I will multiply both sides by 2. That cancels out when you have 4 is equal to 6 plus x. Then we'll subtract 6. And we'll get negative 2 is equal to x. That's how we're going to do this. So now let's try finding our y. So I'll start with ym. 0 is equal to 2 plus y divided by 2. So I'll multiply both sides by 2. And I'll get 0 is equal to 2 plus y. Subtract 2. And we'll get negative 2 is equal to y. So the point I found as my solution is negative 2 comma negative 2. This is my answer. So it's a way we can do this whole process in reverse. Now what I'd like you to do is try this process from letter A on your own on letter B. See if you can do this on your own. Remember that the first point we're given, the A point, is our x1, y1, and the second point we're given, that endpoint, is our xm, ym. So plug them into our given equations, our midpoint formulas, and see if you can do this on your own. Okay, so hopefully you tried this on your own. I'm going to go kind of quickly on this. So I'm going to plug in. So I have 3 is equal to 4 plus x divided by 2. Multiply both sides by 2. 6 is equal to 4 plus x. Subtract 4 and we get 2 is equal to x. So we found our x. Now to find the y, we'll say 0 is equal to 1 plus y divided by 2. Multiply both sides by 2 and we get 0 is equal to 1 plus y. Subtract 1 and we get negative 1 is equal to y. So we have 2 comma negative 1 is our point, is our other endpoint. So that's how we can use the midpoint formula to not only find the midpoint, but also to find other endpoints if given a midpoint. So thank you very much for watching this video, and I hope you have a great rest of your day.